All of you, welcome you guys, welcome you all. Good evening to all of you, welcome you all. How you are doing, everybody? कैसे हो? Yeah, first of all, do confirm this audio video quality. Is the audio video is clear to all of you? Everybody, tell me जल्दी बताइए. Audio video is clear to everybody. Yes, बोलिए. Audio video is clear to all of you. चलो. So let's have some important information from this Unacademy. So this Unacademy is conducting the All India mock test, and with this mock test you will get to know what are the weak areas and where you stand in All India. With that, so you will get to know all your mistakes and all by attempting the quiz and test series only. For that purpose, Unacademy is providing a free mock test for all the students. And what you need to do here, all of you do enroll for this mock test by using a code of BV Reddy. By using a code of what? BV Reddy, and you can have a great learning as well as a great experience you have. So, and these are the features of Unacademy. With this, you can plan your Unacademy subscription for the free of cost without paying any additional charges. You can able to avail it. And Unacademy complete notes are available. The digital form, you can access the digital notes. And these are the new batches we are starting for the GATE 2024. You can find the top educators. You can use a code of BV Reddy to have a great Unacademy learning experience. Use a code of BV Reddy. Right, these are the batch for electrical. These are batches we are running. You can follow these batches to have a great experience. And so these are the features of Unacademy. The plus platform, the plus features are the top educators. You can attend the classes, and then digital notes, test series, and the iconic students will get additional benefits of customized doubt solving features, printed notes, one-to-one mentorship, strategy study program, and interactive open house sessions. Chalo, let's start our discussion. The last class we have discussed about the Gauss Law. All of you tell me. Last class we have discussed about the Gauss Law and we have seen the Maxwell's first equation. Everybody tell me. So any doubt in this Gauss Law or this Maxwell's first equation? Any doubt in this Gauss Law and Maxwell's first equation? Tell me, all of you. We have seen the greatness of Maxwell. That means we have seen the smartness of Maxwell we have seen. So what you understand now here, we used to call the Maxwell's equation. Those are not given by the Maxwell. Those are the contribution of some other scientist. So that's a scenario is happening. But here the entire work was done by the Gauss, but credit is given to the, we are giving the credit to the Maxwell. Fine. Chalo. Let's continue our discussions, all of you. And we have concluded one important information. What we have concluded now here, the flux will depends upon what you tell me, the charges present inside the closed surface only. It will depends upon the charges present inside the closed surface, and it is independent of outside charges. And so here, and take down one more point, Gaussian surface. What is a Gaussian surface is? So wherever you want to find the electric field, so we'll draw one imaginary closed surface. We will draw one imaginary closed surface. That imaginary closed surface is called as a Gaussian surface. The imaginary closed surface is called as a Gaussian surface. Gaussian surface is an imaginary closed surface over which Gauss law is applied. Done all of you? Chalo. So let's take one problem, all of you. Let's solve some problems. Find the electric flux passes through a sphere of radius 2.5 meters centered at origin. Given the point charges, they given as like this. These are the point charges they have given, and the charges has located at the locations you can see now here: 0, +1, -1, +2, -2, +3, -3. At this location they has located. Right. Consider this is the sphere. The sphere of radius is 2.5 meters. The sphere and the sphere of radius of the sphere, we have taken this thing as how much, you tell me? The radius, which is equal to 2.5 meters. The radius of the sphere. Right. Now origin is the center. Origin is the center. Now they are located the charges, you can see now. What are the charges located and which location they are located, you can see now here. The charges located, one charge, if I say this is my x-axis, the charge, one charge located at x is equal to 0 here. Here we have one charge is located. What type of charge is a point charge? And x is equal to +1, we have one charge. X is equal to +1, and at x is equal to -1 also we have one charge. X is equal to +2, we have a charge, and x is equal to -2 also we have one charge, and x is equal to 3 we have a charge. Where is this x is equal to 3, tell me? X is equal to 3. The radius of the sphere is a 2.5. X is equal to 3 means where the charge will lies, you tell me? Outside the sphere, na? The charge will lies outside the sphere. These two charges. Now they are asking to find what now here, the amount of electric flux leaving through the sphere. Now this sphere, which is nothing but this is a closed surface. This sphere, which is called as a Gaussian surface. Now here this sphere is what you tell me now, Gaussian surface. I need the amount of electric flux leaving through this complete sphere. Now according to Gauss law, as we know, my electric flux will depends upon the total charges present inside my closed surface only, right? So my flux, which is given as at x is equal to 0, we have one charge. And how much the charge, you see this thing here, that is 2 power minus x square. The charge is not a constant charge, which is a depends upon the x value. When x is equal to 0, how much the charge, you tell me now? 2 power 0 we have a charge. At x is equal to 1, we have one charge now. How much this value? 2 power minus 1. At x is equal to +1, -1 we have, this is 2 power minus 1. At x is equal to +2, how much we have? 2 power minus 4. X is equal to -2, we have 2 power minus 4. X is equal to 3, can I consider this x is equal to 3 charge? Where is this x is equal to 3, x is equal to -3, the charges lies outside the sphere. Should I consider the outside charges? Should I consider the outside charges? We should not consider the outside charges. My electric flux completely depends upon the charges present inside my closed surface only. So that's why the flux which is given as, which is equal to 1 plus, so this is, that is 1 by 2 plus 1 by 2 plus, so which is equal to 1 by 16 plus 1 by 16. So simply if I get the value, how much will get the totally flux? Tell me. How much you will get this answer? Tell me. I think 2.125. I think so. Check it, all of you. Answer which is equal to 2.125. Done, everybody? Completed? Chalo. Yes, once you are completed, and immediately respond. Immediately respond your answers. So here calculations. So you need to be do carefully. Yes. Chalo. Now take the next problem. A charge Q is enclosed by a spherical Gaussian surface. Is enclosed by a spherical Gaussian surface of radius capital R. If the radius is doubled, then the outward flux is. Then what is how much flux will through my surface is? Tell me now here. I have a sphere of radius is given as a capital R. Radius is given as a capital R. Now, and so we have some charge is present inside my Gaussian surface. Now, what is the flux leaving through this sphere? Tell me. What is the amount of flux leaving through this sphere? And which is equal to what you tell me now here? Q. The flux leaving through the sphere, which is equal to Q. Now I am taking this as one more sphere. So the radius of the sphere, now they made this as a double. So this is 2r. Now, so that means we have same charge is present inside. Now tell me, I have this much. Now they made this as a bigger now. But is there any change of charges inside my sphere? Tell me. Do we have any change of the sphere charges inside now here? This radius now itna ho gaya. Right, now this radius which is equal to 2r, and we have charge lies here now. Can you tell me now here what is the amount of flux leaving through my this sphere? Tell me. Q only now tell me. So that means is there any change of the flux through the sphere? Flux does not depends upon whether you have taken a smaller part or bigger part, bigger area. So the flux will depends upon the charges na. So here how many charges inside now? A charge Q is enclosed by a spherical Gaussian surface of radius. Initially we have a radius sphere of radius R. Now they increase the radius of the sphere. Will the flux changes, you tell me? Will the flux leaving through my sphere changes? It cannot changes, yeah. So it should be same na, हमेशा, isn't it? अगर ऐसा change हुआ तो let us consider here. I have some. So here I have some 10 rupees I have. The 10 rupees I have kept in one small box I kept. Now the same 10 rupees I kept in one big box I have kept now here. Tell me now here what happens now. The 10 rupees I kept in a small box. Okay, 10 rupees I kept in the one bada box मैंने plan किया बड़ा box. So the 10 rupees will remain same or 10 rupees will double triple होगा क्या? Tell me. So then how much the amount the box will contains, you tell me? How it will become 10 rupees will become 1 lakh, isn't it? अगर ऐसा हुआ तो here, so nobody will do any work now, tell me. Nobody will do. Daily what they will do here, they will take 1 10 rupees coin and they will put in one bada room they will place it now here. So that by the end of the day, then if the 10 rupees will becomes 1 lakh. So then koi kaam karne ke jod bhi nahi na. No need to do anything. So we fellows will enjoy the things. Right. Next one. See this thing here. 4 charges lie along x-axis at n comma 0 comma 0 with n is equal to 1, 2, 3, 4. If the charges are the charge magnitude they given as what? N factorial into q. N factorial into q. Then which charges contribute maximum and minimum electric field strength at the origin? Then which charges will contribute maximum and minimum electric field strength at the origin? Right. Now you see this thing carefully. Let us consider this is my x-axis. Here is the origin. We are getting this is 0 comma 0 comma 0. Now we have charges located at this location. Locate now here. When n is equal to 1, the location of the charge you tell me now here, which is equal to 1 comma 0 comma 0. And n is equal to 2. So can you tell me the magnitude of the charge here at that location? N factorial means 1 factorial. Now when n is equal to 2, so it will becomes what we can say here, 2 comma 0 comma 0, that is 2 factorial, and which is given as a 2q. When n is equal to 3, the location of the charge is 3 comma 0 comma 0 on x-axis, and the magnitude is a 3 factorial means what I can say 6q now. And when n is equal to 4, that is 4 comma 0 comma 0, magnitude is a 4 factorial means what we can say here 24. Now tell me all of you. These are the charges we have placed at these locations. All of you. Now they are asking to find which charges will contribute maximum electric field, minimum electric field at origin. So I have to find the electric field at this location due to all the 3 charges. Now as we know the electric field formula, which is given as kq by r square into what now here, ER cap. Since I need only the magnitude only, I don't want any direction, so I can modify this formula as what I can do, E is equal to simply kq by r square. We can do it now, no need of any direction here. I need the maximum minimum means we need only the magnitude only. So can you tell me the electric field caused by the first charge? Even if I say, which is given as, tell me. So that is k into q1. So here q charge, first charge 1 by distance is 1 now. So this magnitude is kq by 1. So tell me the electric field caused by the second charge. That is k into q means what I can say here 2q by r square. How much the distance at origin now here? That is 2 square means 4, which will come as 1 by 2 into kq. Now what is the electric field caused by the third charge, you tell me? That is given as kq means 6q by what now here? 3 square, that means 9. So how much will get, you tell me? That is 2 by 3 into kq. And electric field caused by the third charge, fourth charge, tell me how much, you tell me now. E4 if I say, which is given as kq means 24q by what I can say now here 16 now here. So how much will get now here? E4 value, which is given as what will get now here So which is equal to 3 by 2 into KQ, now tell me. So you tell me now which is a maximum, which is a minimum. Here this is a maximum, you tell me E4 is maximum, and this E2, this is a minimum, this is a minimum. So that means what, which charge will contribute maximum? Now fourth charge maximum and second charge is minimum. So what's the option, tell me now? D. Isn't it? All of you tell me. This is the way we need to solve the problems. Here we have calculated the magnitude, that's why we focused only on the magnitude only. No need of direction now here. Right. Let's see the next one here. 2 point charges, they given like this. The direction of electric field at this location, at some location they are asking. So here they are asking to find the direction of electric field. So now you have one charge at 5 coulombs. Right, now here this charge which is a 5 coulombs of charge, and this location is 0, 8, 0, and this is minus 5 coulombs, and the location is that what. Yeah, so the problems what they will do here, the concept to हमेशा, so here same problem repeat नहीं होगा gate में. Same problem doesn't repeat, but what will repeat now? Concepts will repeat. Only thing is they will add some other. Here we have taken this as some distance, now they will increase the number of charges. That's all. Right. The concept हम repeat होगा, but problem repeat नहीं होगा gate में. And minus 5 coulombs of charge which is located at 0, minus 8, 0. Due to the two charges, now they are asking to find the electric field at this point P. See the locate coordinates of this point P, tell me now x, 0, z, right? X, 0, z. Now you tell me we'll find the electric field because of the two charges. Let us see now the electric field at the charge because of this thing, which I am calling this as a E1. I'll call this electric field which is equal to E1, and the electric field caused by the second charge at this location, which I will call this as a E2. This is the E2. Now let us find this E1 and E2s. So look at now here the distance. Here this distance we will call this as what I can say here R1 bar, and this distance is called it as a R2 bar. So tell me now R1 bar, R2 bar. Here R1 bar which is given as distance means final minus initial na. So which is given as XAX minus 8AY plus Z into AZ. Right. Now tell me now, and R2 bar which is given as what I can say now here XAX plus 8AY plus Z into AZ. Isn't it? Here if you see the magnitude of the charges is same. What is the electric field formula? Basically electric field which is given as what? KQ by R square into AR cap. If you see carefully, now this magnitude K value remains same for both, Q also same, R magnitude. So this formula we have modified this thing as KQ by R cube into R bar, I can say. The whole thing if you see which is constant. This part whole thing which is a constant, now tell me. So I can write this electric field in this particular problem. I can write this thing as simply something K1 into R bar, I can say. So the electric field at this location which is given as what I can say. And here one more thing, here we have charge is also variable charge, not then we can include the charge also then better. Okay, so what I am doing is now here I am calling this thing as the whole thing here simply constant. So that is K1. So this is Q into R bar I am saying. So tell me the electric field to the first charge, you tell me. So which will be given as E1, which we can write. So which is given as total E1 plus E2 hoga na. So total E1 which is given as E1 bar plus E2 bar. Yes, you tell me now E1 bar which is given as that is K1 into Q. First charge is what charge now? Tell me, look at now here. It is a positive charge. So 5 coulombs now here. 5 into what I can say now here. R1 bar. What is R1 bar? Tell me here. XAX minus 8 into AY plus Z into AZ plus that is K1 into charge is a negative charge na, into XAX plus 8AY plus Z into AZ. Tell me all of you. Now the total field which could be given as what I can say now here. The sum of these two I can say, if I take the 5K1 we have taken common, then XAX minus 8AY plus ZAZ minus X into AX minus 8 into AY minus Z into AZ. So finally the electric field, what direction I will get, you tell me. 5K1 into what I will get now here, minus 16 into AY. Here we need only the direction of electric field only na. So what's the direction of electric field? I can say here negative Y directions. What is the direction of electric field, you tell me now here, which is a negative Y directions. Is it fine, all of you tell me? Done. Fine? Yes. Clear now here? Any doubt now, tell me. अगर कोई डाउट हुआ तो बोलिए. चलो, let's move. Fine. Okay. So here and for today, exactly. So here we need only the direction only. We no need of magnitude now. So we need to modify the formula according to the requirement. According to the requirement, we need to modify the formula. Otherwise even we can use a magnitude, but लेकिन magnitude so हर बार हम लिखने के time में, so then it will take more time ना. So it will unnecessarily our time will get wasted. So इसीलिए मैंने k some constant मान लिया. हमको direction चाहिए ना केवल. We no need of any magnitude, right? According to the options, we need to smartly we have to solve the problem. हम स्मार्टली थिंक करना पड़ेगा. सो रफली हार्ड वर्क नहीं है. सो कॉम्पिटिटिव एग्जाम्स के लिए हार्ड वर्क नहीं चलेगा, स्मार्ट वर्क से करना पड़ेगा. फाइन. ओके. So if you have any doubt, let's discuss now. If you have any queries and all, let's have a discussions. So actually, so here, any doubts you tell me. Done. Now let's take the next problem. Take this thing here. Concentric spherical shells of radius they given 2 meters, 4 meters and 8 meters carry uniform surface charge densities. Surface charge densities. They given the densities given as a 20 nanocoulombs per meter square, minus 4 nanocoulombs per meter square and rho s. Now they are asking to find the electric flux density at r equal to 1 meter, 3 meters, 5 meters and 7 meters. Right? Chalo. Here how many ECE students are there in this class? How many ECE students are there? Is all are electrical students or ECE students also there? What of the remaining students? These are the spheres. You see the 4 meters. And they given this is the 8 meters. Right. Now look at now here. What they given now? The charges will have a charges. These spheres will have a charges. What type of charges they given? It is now here surface charges they given. So this first one will have a surface charge density. How much you tell me? 20 nanocoulombs per meter square. And second one have a charge density of minus 4 nanocoulombs per meter square. Next one we have this rho s. All of you tell me. This is the data they have provided. Right. Now you take this as a nanocoulombs per meter square. Fine. Now Suniya, now what they are asking to find. Look at now here. First of all, you tell me now this sphere. What type of charges? These are the surface charges. Surface charges means where the charge will lies only on the surface only. Surface charge means charge will lies only on the surface only. Let us consider here. अगर आपने ये, so if you have considered this as something sphere, if you have considered this, we have considered as something sphere. Is it visible to all of you? The charge will lies only on the surface only. Charge will lies केवल on the surface only lies. Inside इसके अंदर कुछ भी नहीं है. Nothing is inside the sphere. Charge completely lies only the inside the sphere. All of you tell me. Now you see this thing here. If we know the surface charge density, how we can get the charge from surface charge density? That is Q, which is given as what we can say here, the surface integration of rho s into ds. अगर आपने ध्यान से देखा तो here what type of charge density is given in the problem, you see whether that is a uniform charge density or non-uniform charge density. They given that 20 minus 4, they are given it is a uniform. Now it is not depends upon the distance parameter. These are constant values now here. So we can take out the rho s value outside. So this, if I take the rho s value outside, Then integration, surface integration of ds. Surface integral of ds will give what you tell me now here. Surface integral of ds, it will give what now here? Area will give now. So that means what I can say here, rho s. So complete the charge which could be given as what I can say, tell me now here, that is q, which is equal to, this is rho s into what I can say now here, surface area. Is this point clear to all of you? Tell me. Into the surface area. Everybody here, this is what type of charges? These are uniform surface charges. Now can I able to find the charge of the first sphere, q1? How much the charge the first sphere will contain, you tell me? The density which is given as a 20 nanocoulombs, that is 20 into 10 power minus 9 into surface area of the first sphere. Now how much we can say here, 4 pi r square. What is the radius of the first sphere, you tell me now here, 2 square. So tell me how much the charge of the first sphere, you tell me now here, 4 into 4 16, 16 into 20 here, which will give 16 into 32 now here. So that means which we can say 320 pi into 10 power minus 9 nanocoulombs. क्या हुआ इधर? Here they given the, so they given the rho s, surface charge density is given. How we can get the charge from surface charge density, tell me? That is surface integration of rho s into ds will give the charge. So rho s into ds will give the charge. Now we need to see this thing, what type of rho s is a, whether this rho s value point to point, it is depends upon space parameters or not. If you see carefully in the charge density given in the problem, this is a 20 constant, minus 4 constant. These values in this complete sphere, the values are remain same. These are not changes from point to point. Hana boliye, since these are not changes from point to point. Rho s value, what is a rho s value here, you tell me? This rho s value which is a constant, it is not changing with respect to space parameters. So that's why what I can say now, I can take out the rho s value outside na integral. We can take out the rho s value outside. Integration of ds. Now what we have, integration of ds. If I do this, is what type of integral is a surface integral. Surface integration, if I do, what I'll get now, tell me? So this is nothing but then you will get the surface area. If I do this thing here, what you will get now here, you will get this thing as a surface area हमको मिलेगा ना here. That is surface area of what are the figure, that surface area. Now in this case the figure is, what type of figure is a sphere. What is the surface area of a sphere, you tell me? 4 pi r square. Surface area of a sphere is 4 pi r square. So that means what I can say, charge of the particular sphere is given as its charge density into the surface area, which is a 4 pi r square. Whatever the radius has been given, that value we need to substitute. So ये clear हुआ सभी को बोलो? So is it fine to all of you, everybody? Done? Right. Now you tell me now here. So here we got this Q1 हमको मिला. So we got the Q1. Similarly, let us get the Q2 also. Yes, daily we are having the class now. What happened to Neeraj? Daily we have a class, 9 to 10 we have a class. Next, can you tell me the Q2 here? Q2 is the second charge. Tell me the Q2. and which is given a charge of this thing. How much the charge is a? Which is equal to -4 into 10 power minus 9, and then charge density. How much the charge density you tell me now here, which is equal to 4 pi r square. How much this r is a? Radius is 4 now, 4 square. Tell me how much the q2 value. So how much the value of q2, tell me. 4 square means 16, 16, 16 means 256. That is minus 256 na. Minus 256 into 10 power minus 9 nanocoulombs. All of you tell me. Next, we are calling this as a Q3. What is the charge of the third one sphere? Third sphere, which is given as what? Now this Q3, which is equal to rho s into what I can say, surface, rho s into 10 power minus 9 nanocoulombs na here. As usual, 4 pi r square. How much is r value? 8. So 8 square means 8 square na here means so 64. So how much you will get the Q3, tell me. How much I will get this Q3 value? So we have, so here 64 into 4. How much is value? 256 na here. Here I am calculating the charges only, remember. Consider this also nanocoulombs. Okay. So here this is 256 pi into 10 power minus 9 nanocoulombs. These are the three charges we have calculated. Is it fine? Tell me, all of you. These are the three charges we have. So area, we are just calculating the charges present on the each sphere. We are not come to the problem. Wait, problem के बारे में हम आगे आएगा. Wait करो. These are the charges we have calculated as of now. Just as of now we have calculated the charges only. Now अभी हमने, we are going to see this thing here. Look at now here. Here listen carefully. Now I need to find the electric field. Where you tell me now here? So at this location we need to find. To find this electric field, suniye all of you. Here we use a Gauss Law applications. What is the Gauss Law application? What we use is, see this thing here. We have seen the by equating the second term and fourth term, we have the equation which is given as d dot ds which is equal to what we got. You tell me, Q enclosed. Hana boliye, tell me everybody. D dot ds, which we got this thing as, which is equal to Q enclosed. Is it fine, all of you? What is meant by Q enclosed? The charge enclosed by the Gaussian surface. The charge enclosed by the Gaussian surface. Now this formula which we are modifying for our conveniently. Now I am taking the d outside. When we can take d outside, if it is a constant, d value constant, electric field which is constant in the normal direction. So इसीलिए हमने d को मैंने बाहर ले लिया, d. and integration of ds will give the surface area. Whose surface area will give you, tell me? That is the surface area of the Gaussian surface. Whose surface area will give you, tell me? Surface area of the Gaussian surface. Surface area of Gaussian surface. And which is equal to Q enclosed means what? Charge enclosed by the Gaussian surface. That is equal to charge enclosed by the Gaussian surface. Charge enclosed by the Gaussian surface. Is this point clear to all of you? Tell me. Charge enclosed by the Gaussian surface. ये पॉइंट आपको समझ में आया कि नहीं बोलो this thing. By using this thing we can solve so many problems, we can able to solve it. So D, and the D it is perpendicular, so since we can say it is a radial directions, I can use the suffix of R, where the suffix R indicates that is a electric field in the radial directions. In the radial direction electric field is a constant. जो मैंने बोला ये चमका कि all of you, is this point clear to everybody? Hello. Now let's see this thing here. Now I want to find electric field. Where I want to find the electric field, tell me first of all here. Where I want to find the electric field now here? At R equal to 1 meter. Yes or no? First now I want to find the electric field at R equal to 1 meter. Suniye all of you. That means wherever you want to find the electric field with that much of radius, draw a Gaussian surface. So here radius of the smaller sphere, this radius is a 2. R equal to 1 meter means I need to draw, this is my Gaussian surface now inside, and I need to draw, this is my Gaussian surface now, tell me. So here, and with a radius of 1 meter I need to draw here, isn't it? This radius is 1 meter. अगर आपने ध्यान से देखा तो here now you tell me. So with dr into what else I should say now here? Surface area of a Gaussian surface. Now this red one is a Gaussian surface now. What is the surface area of a Gaussian surface? Tell me now here. 4 pi r square. How much is r value? Tell me. 1. And which is equal to what you tell me? Charge enclosed by the Gaussian surface. Now this red one, this is my Gaussian surface now. You tell me now how many charges are inside my Gaussian surface? Inside my red circle, do you have any charges lies inside or not? How many spheres are inside that one? Tell me, do you have anything or not? I don't have any charges lies inside my Gaussian surface, isn't it? So I can call this Q enclosed 0. Is it clear to all of you? Tell me. Is it clear to all of you? Tell me. So I can set Q enclosed 0. Right. So that means what I will get now from this dr, I will get this as a 0 now here. Dr equal to 0, I can say D which is also equal to 0. Everybody, that means the electric flux density at R equal to 1. So if I know D now, as we know D is equal to what now? Epsilon E. If I know D, from this what I can say? E value which is also equal to 0 now. E is equal to D by epsilon. Then we calculated this is where now at R equal to 1 meter. Now let's try this at R equal to some other. Now tell me at R equal to 3 meters we are doing. Now let us do the R equal to 3 meters. Now R equal to 3 meters means somewhere here now. With this I am drawing my Gaussian surface. My this red circle is there now. Red circle is my Gaussian surface. Now you tell me now, same formula we should apply now, tell me. That is dr into what now? Surface area of a Gaussian surface. How much you tell me? 4 pi r square. How much is r value? 4 pi r square. How much is r value now here? With a, what is the radius of my Gaussian surface? 3 na. So 3 square. 3 square means what we can say? Which is equal to 3 square, and which is equal to what I can say, tell me now here. And total charge enclosed. Now here, here inside we have my q1 charge is inside my Gaussian surface. Now tell me. Now the q1 charge is inside my Gaussian surface only now. We got the q1 value. So how much the q1? 320 pi. So that value we can substitute here. So now simplify, substitute now here dr, which is given as, which is equal to 320 pi by what I'll get now here, 4 pi into 9. 4 pi into 9. Isn't it? Which the units will becomes nanocoulomb. Charge is a nanocoulombs now. And you can simplify, you can get this value. This is my dr. From this we can say d, which is equal to, where suffix r indicate the r component. So we can write this thing as 320 pi by, so here, so this is 36 pi into ar cap. That is nanocoulombs per meter square. Nanocoulombs per meter square. Is it fine? Next, and where else we need to find the electric field now here? At 5 meters. At where we need to find now here? At 5 meters we should find. So let us find at 5 meters also. Tell me now, r equal to 5 meters. Now what I need to do here? With the 5 meters of radius, I need to draw my Gaussian surface. 5 meters means here, hoga na, tell me. This is the radius of the Gaussian surface. Now same formula. Tell me now here, dr into what I can say? 4 pi r square. That means 5 square. Now how many charges are inside my Gaussian surface? Tell me. How many charges are inside my Gaussian surface here? We have a 2 charges are inside now here. Those we can say q1 and q2. So we can say q1 plus q2 hoga na. So from this we can get dr, which is given as, what you tell me, 320 pi. Now what is the second charge q2 here? Minus 256 pi. This is minus 256 pi by what now here? 4 pi into 25. This thing now tell me. Now do simplify and get this value. Right, so here which will be dr, which will get it as how much now? 64 pi by 4 pi into 25. So this means what we can say now here? 16, I can say this is 16 by 25 into ar cap. 16 by 25. So from this what we can say? D is given as, what we will get now here? 16 by 25 into ar cap. Nanocoulombs per meter square. All of you tell me this thing, everybody done? Yes, you will get this class, this notes in the Telegram group. You can get Telegram, you can follow me in the Telegram B V Reddy. You can follow me in the Telegram B V Reddy. There you will get the complete things. Okay, fine. In the Telegram, or you can follow me in the Unacademy community. Unacademy community also you will get these things. Done all of you? Next, where else we need to find now? At r is equal to 7 meters also we need to find now. Now you tell me now. Same formula we should apply. Tell me. That is dr into what we can say 4 pi r squared. How much is r value now here? 7 square. When r equal to 7, you tell me how many charges are inside my Gaussian surface. How many charges are inside my Gaussian surface? You tell me. 1, 2, 3. So we have only 2 charges are inside my Gaussian surface now. So here only 2 charges only inside. Third one radius is how much? Third one radius is how much? Third one radius is 8 meters. How the third one will lies inside? What we are doing the r equal to 7 only na. So only 2 charges are inside only. All of you only 2 charges inside. Now tell me now dr. Which will get it as same now here. What will get now here? That is 320 pi. Charge no changes minus 256 pi by what I can say now here 4 pi into 49. 49 and do simplify, get this value. How much will get now here? 64 pi by 4 pi into 49. So from this d, which we can say this as 16 by 49 into AR cap nanocoulombs per meter square. All of you tell me, is this point clear to everybody? Now let's see the next bit. Now what they are asking the next second bit. Here they are asking to find the value of rho s required to ensure the electric flux density d value. How much you tell me? 0 at r equal to 10 meters. At r equal to 10 meters the flux density is 0. So what you do here? Same thing. Can you tell me now here? Can you write the same thing like at r equal to 10 meters? Now draw a Gaussian surface with r equal to 10 meters. Tell me the expression what I will get. That is dr into what I can say here 4 pi r square means what now here 10 square. When r equal to 10 meters, how many charges are inside my Gaussian surface? Now how many charges are inside my Gaussian surface? You tell me. 3 charges are inside now. Third one radius is 8 meters. All the charges are inside the Gaussian surface. Isn't it? Now what they said now here? What they said at r equal to 10 meters, what is the d value electric flux density? How much is value? They are saying that d value 0. Agar d value 0 आई तो then dr value will becomes what now? Tell me 0 होगा ना? That means completely this left side part will become 0, which is equal to what I can say now? This is q1 plus q2 plus q3 होगा ना? Tell me. So that means from this q3, which is equal to sum of the charges must be equal to 0. Tell me now here all the charges. First one, which is equal to 320 pi nano. Yes, minus 256 pi nano. And third one is how much you tell me? That is 256 pi into rho s now tell me, which is equal to 0. These are the charges, you tell me all the 3 charges now. Now simplify, get this value. How much you will get, you tell me? Simplify, get the value of rho s. How much you will get? So this is 256 pi. Pi will get cancelled into rho s, and which is equal to this is minus 64 na. So that means rho s is equal to what we'll get now here, minus 64 by 256. So how much is rho s value, tell me? Yes, how much is rho s value will get, you tell me? 1 by 4? Yes. So finally rho s value which is given as minus 0.25 nano coulombs per meter square. Done everybody? बहुत बढ़िया. Tell me this thing. Right. Like this we need to solve this thing here. Fine. Okay. Done. So all of you revise the today's problems, and that's for the today's class. We'll meet tomorrow. Tomorrow same thing, we'll continue the remaining next concept we are going to continue. Right. Fine. Okay then, see you. Bye bye. Good night.